Thank you. It's a pleasure to be here. Yeah, the working title was a bit different. Just a little bit about me. I'm a backend engineer. I work on the core backend team at Yelp. And I got quite a bit of content. I'll try to be quick enough so that we have time for questions. One quick word about my employer, Yelp. We have a website and an app. We help people find great local businesses. We're actually pretty popular, especially in North America. We have over 30 million monthly unique users on our mobile app. We have over 130 million reviews. So we do work at scale, which people seem to care about. So what I'm going to be talking about, what are type annotations and why should you use them? This will be very short, one quick slide. This talk basically is hopefully starts where the more introductory talks end. So I hope you already know a little bit about type annotations. We're going to talk to how to incrementally migrate an existing code base to using type annotations. What are some of the issues you might be encountering? And the last part, which is actually going to be a relatively big part, is how can type annotations help across services, so across network boundaries, basically. One thing I'd like to say is that I'm by no means an expert on type annotations. I'm just going to talk about what I learned as a user. So with a grain of salt, let's start. Oh, and I'm also going to use a bunch of source code, so if that's not your thing, I'm sorry. I think it fits with with my talk. That said, if you want a bit more introductory talks or talks that explain a bit more the why and the how, in the more basic sense, there were two actually really great talks at PyCon US earlier this year. One by Carl Meyer from Instagram, the other one by Greg Price, who is now at Zulip, was at Dropbox previously. So I encourage you to check them out. Really good talks. But let's give you a very quick, hopefully reason to use type annotations. So if you have this code, super simple function, takes a string, returns a string. We call it with an integer. We'll get an error, not at runtime, but we'll talk about when in a second. Now you might say this is a contrived example, and by the way, this code works perfectly well with an integer. It does, when you run it. One reason, yes, for type annotations is to help you find bugs and issues with your code. The other one is to actually document your code. So what this basically does, it tells you that your documentation is wrong or incomplete, which I think already is a big, big advantage because the documentation is now part of your code. And if it doesn't match reality, you get an error. We all know otherwise what happens with documentation. It gets out of date. And the reason why many companies with larger Python code base use annotations is more functions like these, where you get items and you don't know what items is. Actually, this is basically an example I took from Carl Meyer. And we know it probably has a value attribute and that has an ID, but we don't really know. And it gets even worse if it's a dictionary instead of some other type of object. So as you have a large code base that multiple people work on, you probably joined the company years after this code base was started. Type annotations really help with understanding what's going on. So let's talk about how you might migrate this existing code base, large code base, to type annotations. The goal here is that we want to end up that all code is type annotated. We want to do this incrementally, so this is not going to be a code size where just one person can sit down and spend a day or two or three and just burn through it and everything is annotated. And we want to make sure that for the code that we have already annotated, that we do run checks on it and make sure we gain value out of those annotations. To check annotated code, we're going to use MyPy. I assume most of you have heard about it. It's the de facto standard type checker. It's a sort of linter that you just run on your code, just I don't know, Flake 8 or whatever. And it will tell you when there are issues with your code. It's still like not at a 1.0 release. There are some small issues still. We're going to talk about a few of them. Yeah, but it's really good and it's improving rapidly. I'm also going to be using the Python 3.6 type annotations because they're just so much better. You can use type annotations with Python 2 or earlier versions of Python 3. It's just because it looks better. There is actually another type checker, in this case for Python 3 only, from Facebook or Instagram, like that area. It's supposed to be much faster, especially for large code bases. We're not currently using it internally at Yelp, so I don't have any personal experience with it, but you should definitely check it out. Yeah. So let's get started. How do we actually enforce annotations? Like MyPy has a lot of options, and we need to configure it correctly so that it does what we want to do. Again, like our goal here is to, on a file-by-file level, make sure code is annotated. So that whenever somebody changes something, we know if the code is annotated or not. So the first three configuration options basically say that non-annotated code is an error. The next two ones say that any code that I'm not like providing you as an argument on a command line, like any file, yes, you need to follow it to understand what's going on, but don't tell me about any errors or problems in there. And then this is an important option. We want to make sure that you handle none correctly. This is like a big source of bugs and issues in many languages that don't handle none explicitly. And even in Python, oftentimes, yes, you kind of make sure like it's a list or an iterable or whatever, but actually, like, are you making sure that it doesn't crash or throw an exception when it's none? And for the cases where it can be none, you need to be explicit about dealing with it. This, I think, is going to be, I'm not sure if it is already, or it's going to be the default in MyPy, but just in case it's not, you should probably set it. And this is kind of like, I would say, like a recommended by me, so my personal preference for how to do it. There's like actually a strict option in MyPy that is stricter than this, but you do need to find like a trade-off between how much time you invest in writing the perfect annotations and you know, getting code to production. So how are we going to enforce these annotations, or that people make annotations? We're going to use a tool called pre-commit. It's an open source tool, open sourced by Yelp, that provides all kinds of hooks that you can run when developers commit code. There's like a lot of hooks for a lot of different languages and file formats. The Python support is really good because we're like a big Python shop. Yeah, that's what we're going to make sure that that code is annotated. So let's take a look at how to configure it. Basically, we need to add a separate hook that is MyPy. One thing we're going to do is we're going to pass it a special config file, the one that I showed you a couple of slides earlier. Yeah, this will make sure that that any code that is being touched is fully annotated. To install pre-commit, basically you run a command just like this. Typically, you can do this when, like, as part of your test suite or as part of your like make or setup or whatever step. So just to make sure that developers have this installed. And then when you run it, or when you basically commit something, this is how it could look like. So you see there, like, there's a bunch of tests or hooks that run on the files I touched. The one where it says skip, they don't apply to that file type. And you can see the MyPy hook that we just configured is failing because apparently I modified a file called media.py, and yeah, the get photos future thing I used, like, it has an incompatible type. Also, I forgot to add a return type annotation, and also an annotation for one of the arguments in that function. One thing I'd like to say is that all of this is like based on the team, like everybody agreeing that this is a good thing. So you can definitely skip individual pre-commit hooks or all of them. This is like when I say enforce, it's just like making sure people don't forget, not forcing people to do things. I'm going to address this a little bit at the end, but obviously everybody should be on board that type annotations are a good thing. But we do want to run MyPy also as part of our test suite to gain some of the advantages of having type annotations. So we're going to use a less strict config option for that. So it's totally OK to have non-annotated code. Also, this is going to be run on all of our code, not just files that were changed or touched. Yeah, what is going to happen once you start with type annotations is that you're not going to notice like a lot of issues being caught by MyPy when you run it as part of your test suite. That is because as soon as it encounters a function that is not fully annotated, it kind of like uses this any type, which can mean it could be anything, and it won't basically stop type checking, and the value that function returns will also be any. So it'll take some time to get started to really see results, but remember that those results are going to come, and that already, like from the first annotation you add, that's already documentation, so that already adds value to your project. That said, it can be like a little bit tedious to annotate everything by hand, so there's tools now that can help you get started. Probably the best one, as far as I know, or as far as I have tried, is MonkeyType, also by Instagram, which really helps. It can not only can it gather type information as you run your code and write that in a file, it can then also use that information to automatically annotate your code using the Python 3 annotation syntax. That's a great way to get started. Just remember that it's not a magic bullet. Like a developer needs to go through those annotations, check them. Sometimes they are too strict, so you can loosen them up. Sometimes they can just be plain wrong. So if you run them as part of your test suite, you might see like a bunch of like mock annotations in there, which obviously you don't want to have in there. Yeah, and the second tool that I think comes out of Dropbox is PyAnnotate, which we've also tried internally. It actually also works reasonably well. The main drawback is that since, as far as I know, Dropbox is still like very much a Python 2 shop, they do the annotations in this comment form that works in Python 2 as well. But if you are on Python 3 or Python 3.6, my personal preference is to use that syntax. It looks much closer to like types in other languages, so that's maybe the main drawback here. So, but one of the important, like the most important thing for type annotations is to type your data, like I said in the motivating slide. Actually making sure you know what data is passed around is super important. I mentioned the dictionary example. When you're there and you join and you get ramped up and you have like, well, in our case, we work a lot with businesses, and you have like a business dict, and then, well, what's in there? I don't know. And it gets even worse if you then have functions that like modify the data along the way. So all of a sudden it looks a little bit different, and do I already have the mutated form here or still the original form? I don't know. So that yields like a lot of like productivity loss, bugs, frustration. And named tuples are a great way to kind of deal with that. I personally like them a lot. Yes, in Python 3.7 we have now data classes. Pick whatever you like best. The good thing about named tuples is that they prevent mutation, so you can kind of like be more or less sure that once they are created, they are not going to be modified. As you can see here, like I'm using the new Python 3 syntax for named tuples. I think it's great readability. You can nest them. So here, photos is actually like an iterable of photo. Photo is like another named tuple that I'm not showing here. Yeah, and I think that's really great. Like it's really clear what your data structures look like, and we probably want to use those. Now, there's also a way to type your dictionaries if you don't want to or cannot use named tuples. As you can see, this is actually like a very similar syntax. It's basically just a different base class. And unlike maps or hash maps or whatever like dictionaries are called in other languages, in Python you can have different types based on the key, like I'm doing here. It will distinguish based on the field name what the type of the value is. So let me show you an example. In this case, I don't know if you can even like spot that, but this code, these 3 or 2 lines really only, it has a bug. I'm taking the business dictionary and I'm calling the get function and I'm saying give me this address to field, and if it's like none, then use the empty string, because I don't want to like I'm trying to be a good developer, preventing like issues with none when the code down the line expects strings. And this is really like an insidious bug, because this will work at runtime 100% of the time. It will never crash. It will never raise an exception, but it will also never return anything else than the empty string, because I forgot the D in like the second D in address 2 is missing. So unless you have like really good test coverage and you like, you know, because you know like your code is not buggy, so what happens is your test fails, and then in your test mock or whatever, you also like use address 2 with just 1D, and all of a sudden your test passes. All of these things have happened already. So this is like pretty bad. But if you use like here, like I'm using this annotation of this business dict that we see up above, and what will happen is that MyPy will tell you with the code as written here that business dict has no key address 2. So even if you need to, for some reason, continue using dicts, using the time to write these typed definitions of your dictionary, and then using them just for annotation. Like the business dict class, you can actually use it in code, so you can instantiate an instance of it and things like that. But even if you just use it as an annotation, it works really well and can help you prevent issues like these. Then you're on your own. So it won't, I don't think it can know like, so what I didn't mention, MyPy like is a static type checker. So all of this, like it has no effect at runtime. So if at kind of like quote unquote compile time, or just by looking at your source code, it cannot figure out what the name of the field is, then because it's kind of like dynamic or whatever, the type checker won't help. Does that answer your question?
If the value comes from something like an enum where it is possible to figure it out, can it do that?
I don't know if it does do that. That's like very specific. I would need to test it. Yeah, but that said, I hope maybe you are convinced that you know, it's a good idea to use named tuples. So the question is, how do you do that? One thing we could do is we could say like we have our named tuple definition, and we actually like use that as the source of truth of how our data should look like. And like we might get dictionaries from some like external data source, JSON or whatever. So let's write a small helper function that converts that dictionary to a named tuple. That's what it looks like. I'll gotta speed along a little bit. We're going to use this helper function to see like some of the issues that we might run into when we type our code. So as you might notice, this function is not annotated, so how would we annotate it? One first try might be we just use the named tuple type. So we say like NT class here is, well, it's not a named tuple instance, so it's a type of a named tuple instance, and dict value as well is pretty clear, and we return a named tuple. This doesn't work because what we return is not a named tuple instance. We care about like what specific named tuple it is, not just a general named tuple. About the second arrow, we're going to see about that in a second. So what do we do here? We learn about generics. And we try to use those. We create like a type var here that is bound to named tuple. It kind of like says whatever class or type this is, the base type must be named tuple. And then we use that here, and we say like whatever like class you pass into this function as argument, we're going to return an instance of that as output. So that should fix the error we saw earlier. Unfortunately, this doesn't work either because of the fact that we cannot use named tuple as a base class. That is also the reason for the error on the slide, for the second error on our first try. Named tuple is actually not a class. It's a class constructor that returns a class that there's actually like no common named tuple base class. So what we need to do here is we need to use protocols as, which is like a relatively recent but really cool MyPy feature, which implements or is basically the solution to duck typing. So we can say like, hey, this is how this argument or this type behaves instead of saying like, hey, it's an int or whatever. And here we can say like, hey, we need something that has like an underscore fields attribute. It has like an underscore make method. And then we return like an instance of that. So here we say, hey, it's a protocol, fields, make. Then we can say that is kind of like our base type. Anything you pass in here, we're going to, needs to conform to that, and all of a sudden it works. I'm going to quickly go through, we might not have time for questions at the end, some of the other issues. So if you do use named tuples, it turns out like count and index are like pretty common attribute names. But there is a base class actually to named tuple, which is the tuple. So that is actually the common base class for all named tuples. They have a count and index method. So if you use the named tuple like this, it will actually work. You basically just need to silence these MyPy errors. Just something to know. Another thing I'd like to mention, if you have a larger code base, maybe you have a descriptor, so like an object that manages an attribute or a property of another object. In this case, we have this set once property descriptor, which makes sure you can like set the property once, but then only read it, never write to it again. It's like a generic class. We can see here like two types, the type of the object that we're managing the property of, and the type of the value. We use that here in get and set. I'm just going to go through this. The slides are online. And here we can see we create a concrete type. BizApp context, by the way, you use strings if you need to use a type that is not fully defined yet. And we say like the biz user ID in this case is an integer, and MyPy will understand that biz user ID, like you can only assign ints to it, and when you read it, it's an int. I'm mentioning this because descriptors are not yet documented, so if you want to do that, please do so, open a pull request. Another thing you should be aware of, MyPy doesn't support recursive types, so anytime you have a sort of like tree or graph-like structure, it won't work. You'll get an error. There's a ticket 2, like a solution to this is basically to ignore these errors and then use like the cast function that MyPy provides to annotate by hand. But typically whenever you have like these kinds of data structures, you kind of like lose type information. So let's try to get quickly through to my last part of the talk, how to do type annotations with distributed code. Like a problem there is really like testability. How can we make sure that like, yes, when we have our code calls several other services, that all of this works, that we like the data we're receiving and that we're using the right format. At Yelp, we have an API specification. We use OpenAPI. From that, we create a client library that we then use to make API calls. Just quickly, this is kind of like how an endpoint looks like. So it's a GET request, that's the URL, and we return a business object as response. That is defined like this. Looks very similar to the like named tuple definition or the type dict definition, just maybe a little bit more verbose. And this is how we make with this like client lib that we have at Yelp. This is how we make the call. It's actually like, for those who know, it's the wrapper around the Bravado library, which is open source. So you can see like for us, it seems like we're dealing just with Python objects, and then it does all the network stuff in the background. Here we create the client, then we make the call. This actually like makes the call. And so let's write a small helper, or yes, a small helper function to get the review rating from a business, which is the aggregated rating of all of the reviews. And let's write a test for that, because that's mainly the problem, right? Like typically you have to do end-to-end tests or whatever to test network code, but maybe we can use mocks and get away with it. So if we do that, we just use a mock here and kind of like have a fake business, and then we set that as return value. It's like a little bit unwieldy, but it works. Like here in this case for our like client, our mock client, and this test passes. Now what I didn't mention, I'm going to go back a little bit here. Review rating is actually of type string. That's for historical reasons. This is actually like an example that we do have at Yelp. There were issues with like floats and serializing and deserializing them in earlier Python 2 versions. Not a problem anymore, but that's still the endpoint definition. So actually, this code has at least an annotation bug because it says it returns float when in fact it returns string. And then if down the line the code like gets the wrong type, there's probably going to be a runtime issue. So our test passes, but it's actually like the code has a bug. So what can we do here? How about we take the API spec and we write some code to generate annotations from it? And let's start with the model stuff, so like these data objects that I showed you. This is kind of like a class that mimics what I've shown you in the OpenAPI spec, and we see review rating as a string. We want people to have that generated, like we don't want people to type that. So let's use that. This is the same function, just repeating it so that you know what I'm talking about when I show you the new test code. And this new test code now doesn't use a mock, but uses this model class as a return value in our code. And if we do that, we actually get an error from MyPy because it knows that the business model that we have generated, review rating is of type float, so is of type string, so I shouldn't assign a float. But can we even go a step further? So this like very dynamic client object that I've shown you here that basically like reads the spec and generates these attributes and these methods. Can we annotate that as well? That would be really cool because just these model classes, even if we auto-generate them, people need to like manually like add annotations to their functions. Yes, you can use them in tests like I've shown you, but we also want like our non-test code to, to have annotations. And it's actually possible. So this is like a shortened version of what we have at Yelp. So basically, you create like, and all of this, I should really reiterate that needs to be generated. So in the end, you don't have to like manually do any of this. So yeah, for this business service, we have this like business service annotation. It has like, well, in this case, one attribute, the business. This is the client.business. Now it has an annotation. It's a business resource. And what is a business resource? Well, the business resource has this business info method. So there, we now know it gets one argument, business ID, and what the type is. So if we call this thing the wrong way, MyPy will give you an error. And, and it will return like a future that is defined below that is a concrete type, like we pass it the model that it's returning. And so if we automatically get all of these type annotations, and MyPy will complain if you do this network call incorrectly or if you use the data it returns incorrectly. And all of that, like modern IDEs like PyCharm, even give you IntelliSense and auto-completion and all of that stuff. So, takeaways. Annotate your code to improve documentation and catch bugs earlier. Fine-grained data structures, type data structures really help understand the data flow of your application. Reduce the number of tests you have to write, especially make the tests you do write more valuable. And you can use generated annotations to type check communication across network boundaries. So check us out on social media, especially the engineering blog. We are hiring. Please come talk to us at the booth. And you can find the slides over there. Thanks a lot.